Hello, class. Let us start with problem number 7.2, number 1. Now, I like my car. You probably like your car. I'm certainly very attracted to my car. Now, how attracted am I? Well, let's find out. Now, imagine, if you will, that I'm standing here and my car, my beautiful, economy electric car, and it doesn't really look like that, is sitting 10 meters away. So there's 10 meters between myself and my car. My question is, what is the force of gravitational attraction between me, my 108.9 kilogram self, and my 1,567 kilogram car? What is the gravity between us? Because according to the laws of gravity, every object is attracted to every other object. So there must be some gravitational attraction between us. Now, the law of gravity says that the force of gravity is equal to big G m1 times m2 over r squared, or sometimes referred to as d squared, whether you're thinking of a radius or just a distance. We're going to say r squared because your book says r squared. So, the force of gravity is equal to big G. Now, big G is 6.673. I think it's 3. Yes, it is. Times 10 to the negative 11. Now, notice this in scientific notation. I would highly recommend for these gravitational problems, you tend to have usually really big, really tiny numbers. Please use scientific notation. So myself, I'm M1, am 1.089 times 10 to the second. My car is 1.567 times 10 to the third kilograms. Kilograms in both cases. The distance between us is 10 to the first squared. By the way, 10 to the first, well, 10 squared is 100. Why don't we just save ourselves a step and go ahead and just write down 10 to the second. How does that work for everybody? So we're just going to say 10 to the second. 10 to the first, 10 to the first is 100. 100 is 10 to the second. We're just going to save ourselves a step there. So, talk is cheap. Let's calculate. Now, the beauty of keeping it all in scientific notation is you can simplify your problem. We're just going to forget about the tens, forget about the tens, forget about the tens. Let's just deal with these numbers. 6.673 times 1.089 times 1.567. You just multiply them together. When you multiply those together, I got FG is equal to 11.39. Now, let's deal with scientific notation. Now, this is very easy. When you're multiplying these things, it's really just addition. 10 to the 11th, negative 11 times 10 to the second, times 10 to the third, divided by 10 to the second. Well, all you got to do is times 10 minus 11 plus positive 2 is minus 9, plus positive 3 is minus 6, minus positive 2 is minus 8. So it's 10 to the negative 8. And by the way, this would be in newtons. Our answer will be in newtons, the force. We usually don't do it in scientific notation. We always put the decimal after the first one, so we have to move the decimal place over 1. So we get FG. Now, by the way, if decimal place gets moved over 1, we're going to have to change this. So 10 to, because 1.1, round to the 4, times 10 to the negative 7. Roughly speaking, the force of gravity between myself and my car 10 meters away is equal to about 1/10 millionth of a Newton. It's a very small force, 1/10,000,000th of a Newton. It's a tiny, tiny, tiny force, but it's there. Now, let's just think about your car. Your car is probably bigger than mine. That's going to make the force stronger. On the other hand, you're probably smaller than me. That's going to make the force smaller. So bigger car, bigger force, smaller you, smaller force. They're probably going to cancel each other out. You are probably going to get a number that's very close to this number. Because the distances are the same, your car might be bigger, you're smaller. You may end up with a number very, very close to this one. So, good luck. We're all rooting for you.